Okay, so continuing on with combinatorics, a variety of questions to practice. This one says determine n if nc2 equals 28. So this is really an algebraic question, right? It's an equation to solve. Remember, nc2 is n factorial over n minus 2 factorial 2 factorial. So that's the equation that we have to solve. So then you remember, okay, you can show it if you want. N factorial is n times n minus 1, and then times n minus 2 factorial. So you could show it like this, so that it's nicely simplified. It says these divide out. Okay. So then you could also multiply through by 2, or 2 factorial. 2 factorial is 2. So you can multiply through by 2 factorial. Those divide out. And so then we get, expand the numerator, n squared minus n equals, that's going to be what, 56? And you can factor that. Remember, n has to be a natural number, so you get a negative.
I mean, there's probably some theoretical math somewhere.
Saying that on the cumulative, it was the last test where it says indicate or label, or just need to see the points indicated of points with integer coefficients. And I got some people giving me this as a point, or that as a point. Those are not integers.
What was the question?
Okay? You had to graph the log function and indicate integer points with integer coordinates. Those are not integers. Just say. Okay, so factor it, and then you choose the positive. Okay, then next one, algebraically show that those are equal. I'm just going to do like a verification here. So 10C4, what is that? The long way is 10 factorial over 6 factorial, 4 factorial. And then obviously you can figure the value out. The right side is 10C6. That's 10 factorial over 4 factorial, 6 factorial, which is the same. Order in the denominator doesn't matter, right? So those are equal. Why? Well, if you think about this, you have 10 items. So you have 10 items. In 10C4, you are choosing groups of 4. Okay, so think about it. If you have a group of 10 and you are choosing a group of 4, how many are left when you take one group out? 6. So for each group that you are choosing, groups of 4, what's left over is the same as what you would get if you're choosing groups of 6, right? Because really, when you take out those 4 people, that's one group of 6 people left. You take out a different group of 4 people, then there's another different group of 6 left over. So it ends up being the same thing. Mathematically, you can see it, but that's why. You're taking a group of 4 out, so the group of 6 is left over. And that the people in that group will then have to be different for the next group of 4 that you take out. And then the next group of 4 that you take out. So basically, you're either, if you want a group of 4 or a group of 6, you're going to get the same value because it's going to be the same number of ways of doing it. Because 4 and 6 add to 10. Okay, so that's always going to happen, that if you have the same n value, and these values add to the n value, then the combinations will be the same. So if this was 10C3, I know that that's equal to 10C7. Because 3 plus 7 is 10. If I had 10C2, that's going to equal 10C8. Okay? But it would not equal 10C4, for example. Okay? That's not very good grammar there. I'll just take out the word you. Choosing groups of 4 is the same as choosing groups of 6 for every group of 4 and the remaining people. Objects, I guess I should say. Okay, so choosing groups of 4 is the same as choosing groups of 6. So for every group of 4, the remaining objects will be a group of 6. Okay, question 5. You can even do question 5 the long way. 5 points lie in a circle. Determine the number of straight lines that can be drawn using any 2 of the points. Okay, so 5 points lie on a circle. Number of straight lines, do it the long way. So 1, that's not very straight, but 2, 3, 4, 5, 6, 7, 8. And then around the circle, oh yeah, I forgot this, 9 and 10. Okay? Yeah. Okay, so there's 10 different lines that you can join between any 2 points. Think about, you have 5 points and you're joining 2. So you're choosing 2 points to join up. Find the value of 5C2. Is it 10? Yep, because remember, 5C2 is 5 factorial over 3 factorial, 2 factorial. So this simplifies to 5 times 4 divided by 2 is 10. Okay, order doesn't matter when you're choosing 2 points, right? If order mattered, then that would be double that because you want 1 point to the other, or the last point back, right? So order doesn't matter.
Like most like real life situations, order doesn't really matter.
Yeah, it depends on the situation. Any of these groupings, order is not going to matter. Okay, so then number of diagonals. So diagonals are not on the outside. So this is for a pentagon, 5 sides. Okay, it doesn't have to be a regular pentagon. It can just be any 5 sides, right? It doesn't say regular. And so now you're joining up the diagonals. So same deal. I'm going to turn this around just a second. I join up with diagonals here, like I did there, so here, I'm not going to join that. That's not a diagonal. So that's equivalent to this one. I'm not going to include that. So I would have 1, 2, 3, 4, 5. Okay, so joining 2 points out of 5 in a circle. Okay, that was 10. Now we get 5 diagonals. So what we're doing is we're subtracting the edges of that pentagon. Doesn't matter how many sides the pentagon has, or the polygon has, right? This will be the number of points, okay, which is equivalent to the number of sides of a polygon. You're choosing 2, but then we have to subtract all the edges. So this is going to be that's in a particular case for a pentagon. Then for a polygon with n sides, well, n would be equivalent where 5 is, so n choose 2, and then you subtract n sides. Okay, so we don't give you those formulas. We ask you for the number of diagonals. You have to think about what it is. Okay, we're not giving you that. Okay, number of triangles that can be drawn. Any 5 non-collinear points. So again, that's like on a circle. Or it doesn't have to be, they just have to be non-collinear. So to get a triangle, we need to join up how many points? 3, right? So there would be 1 triangle. This gets a little hard to. 2 triangles. 3 triangles, 4, anyway, it's the same diagram, but to actually come up with the triangles gets harder to distinguish it. You can shade it if you have colors or something. But so 5C3, what do you think? 5C2 and 5C3, what have we just learned? They're equal, it's going to be 10 as well. Okay, so the actual number of triangles in there. Okay, I'm going to leave question 9 because that's kind of similar to ones that we've already done. Remember that bracket notation is just another way of combinatorics. So I'm going to leave that for you to do. Those of you that play sports and have leagues, this is actually relevant. If you had to organize a tournament and you had 10 teams, how many games must be played if each team plays every other team once? Okay, so order doesn't matter. We're not talking about who's a home team, who's an away team, that kind of thing. You're just playing 2 teams playing together. Okay, so, and you have 10 in total, so you want to know all the groups of 2, because order doesn't matter. So that's going to be just 10 choose 2. Okay, and then the next one, we're told how many games, and we have to work backwards, so I'll just set it up, and then you can do the algebra stuff after. So during round-robin play in a badminton tournament, there were 210 games between the mixed doubles teams. If every team played every other team once, then algebraically determine the number of mixed doubles teams. So we're working backwards. So the last question, we knew the number of teams, and we needed to know how many games were played. They played once. Now we know 210 games were played. We want to know how many teams, and the 2 teams play at once, play each other, right? So then here, again, I'm just going to do the first step. and you can finish. Okay, a couple more questions we've gone through. So you're going to do 11 and 12 as well on your own. It's basically algebra solving equations. This is a numeric response type question. 5 statements are given. You're told 14 different fruits are available for a fruit salad at a cafeteria. Johnny orders the $3.95 special, I guess to say, which contains any 5 different fruits. The number of different fruit salads that Johnny can order can be found using. So in this case, a fruit salad, the order doesn't matter. Sometimes we might be of a question like an ice cream cone and say certain order. You have to have the vanilla on first and then the chocolate or whatever. Order matters. This doesn't. It all gets mixed in together. So 14 C5 would be my first instinct, but take a look. I don't see that particular notation. Okay? What is equivalent to that right away? The different notation for combinations. Well, yeah, that is it, but this statement is the same as this. It's just a different notation. So statement 5 for sure. And then based on what we learned a few minutes ago, if we have the same n value and the r's add to n, then those will be equal as well. 14p5 is never going to be the same as 14c5, right? Order matters. There'll be more. This is not going to be from a combinatorics. It always has 2 factors in the denominator. This one would be, again, you would be dividing out a 5 factorial, so then it would be like a permutation. So there's just those 2. Okay. All right. So this is a little bit of a combination of permutation and combination. So combination, no pun intended, of the 2 types of questions. So it says determine the number of different 4-letter arrangements. So that's a permutation, right? You're going to arrange the letters. You're going to use 2 letters from the word smile and 2 from frog. Okay, so that part, deciding which 2 you're going to take from each of those words, is a combination. Then you're going to take those 4 letters and arrange them. So 2 letters from the word smile, well, there's 5 letters here, there's 4 here. So we have 5, and we're choosing 2 of them. That gets you all the possible letters from that word. For each of those, you have to choose 2 from frog. Okay, so that gets you all the different letters that you're going to use. But then for each of those 4 groups, groups of 4, you have to arrange them. So then think about arranging 4 is you can use 4p4, you can use 4 factorial, up to you. Okay? But it's a multiplication because you have to figure out all the groups of 2 letters from each of those. Then that only tells you which letters you're using. It doesn't tell you the order. So you have to get all the orders for each of those groups of 4. Okay? So that one kind of involves both properties. Okay, a little hint on this one, be careful. It says determine the number of different 5-letter arrangements that are possible using 3 letters from the word tab and 2 letters from the word chalk. So 3 letters from the word tab are only 3 letters, right? So 3C3 is just going to be 1. Okay, but problem is, this has a repeated letter, A. So you kind of have to treat these in cases, okay? So you want to say, okay, well, if I have 3 letters from the word tab, so tab here, right? So you're going to have all 3 letters there. If I choose 2 from here, I'm going to first choose 2 that aren't A. So then I don't have to worry about repeats, okay? So that's just one way. So I'll do 3C3 if you want to just show it like that. Then from try, I'm just going to use CHI. Okay. So maybe I'll put that down here actually. Okay, so all 3 there from chai is CHI. I'm going to, that's 3 letters, and I'm choosing 2 of them. Okay. And then I have to arrange those. Right? If I arrange those, then for this particular case, it'll be 3C3 or just 1 times 3C2 times 5P5 or 5 factorial. That's just like the last one we did. Okay. Okay, and then here, next case would be all 3 of those. Okay, and then we have to have an A and then one other letter. Okay. So from try, if we have an A, that's 1A, 1C1, and then 3 non-A's to choose one of those. Okay, so that's guaranteeing that we have an A. Because if we don't split this up into parts, some of what we'll do will maybe have 2 A's, some won't. But remember with repeats, we need to divide by the repeats. Right? If we have 2 A's, we have to divide by 2 factorial. And so if we don't know which are involved both A's, we're dividing when we shouldn't be, or not dividing when we should be. Okay, so this will guarantee that we have TAB, A, and one other letter. And then we arrange those. So this will be 3C3, 1C1, 3C1, 5. Now, these are both worth 1, right? So let's actually do that. So that's worth 1. 3C2 is 3 times 5 factorial. So what's that? 120 times 3 is 360. This is 1 times 1 times 3. So it ends up being the same. Oh, no, sorry. Forgot. What did I forget to do with this one? Divide by the repeats. That's the whole point of doing a separate case. Okay, so then that's going to be 360 divided by 2, which is 180. Okay, so in your booklet, so we've done to 15, then a bunch of practice questions. Exercises for combinations, answers are there. Then practice on permutations and combinations. Okay, answers are there. Probability involving permutations and combinations. So take a look at that basically. Kind of like what I was talking about, Lotto 649, or probability of getting 4 aces, right? So you find the number of ways ways of arranging or grouping out of the total. Okay, so that's a bit of an extension on that. Lots of practice on that if you want. And so we'll get started anyway on Pascal's triangle until wise time when you have to figure it out.